we now want to look at how we can estimate the mode. How do we determine it for grouped frequency distribution? No longer on grouped frequency, okay? Now, there are two methods that we can use to determine the mode for grouped frequency distribution. One of the methods is by calculation, where you use the formula. Of course, you see the formula on the board here. And then the second is graphical method, where we make use of the histogram. You would recall that under statistical tools used for data analysis, we already have dealt with how to obtain the mode from histogram. Is that okay? So our focus here is going to be how to obtain the mode by calculation method. Is that okay? So if you want to obtain the mode using the formula method, what do? The first thing is to identify the class that is known as the modal class from your table. Alright, so you go to your group frequency table, look at that table, identify the modal class. And what is the modal class? The modal class is simply that class in that table that has the highest frequency. So all you need to do is go to the frequency column, check. Alright, what is the highest number in that frequency column? That highest number, the horizontal row, alright, of that highest number in that frequency column is your modal class. Does that make sense? So once you're able to identify the modal class, the next thing you need to do is to apply equation 9. That's the formula for the mode. Now let us look at this equation, okay? Mode is equal to x subscript mo plus open brackets f subscript mo minus f subscript mo before. You notice that I read this mo negative 1 as before, because this is not like minus 1. Take note. That is not what it means there. Divided by 2 times fmo minus fmo before minus fmo after. You notice how I read this mo plus 1, right? This is not like mathematical plus, as if you are adding 1 to this mo, right? I'm going to interpret the meaning of this once I'm done reading out this formula. So enclose this in bracket and multiply by what? C. Now what does these terms represent in this equation? Let us look at them. X subscript mo. That is the lower class boundary of the modal class. Remember, you've identified the modal class already. Is that okay? Then fmo means the frequency of the modal class, which is that highest occurring frequency. F subscript mo before means the frequency of the pre-modal class. That is the frequency of the class before the modal class frequency. Just imagine that this is your table, alright? We have your table this way, and then you were able to identify this to be the modal class. For example, let's say this is the modal class, and this is, let's take this to be our frequency, for example. Okay, let's take this to be our frequency. And having identified this row as the modal class, it means that this is going to be the frequency of the modal class, FMO. Then this FMO before means the premodal frequency. That is the frequency before the modal class frequency, which happens to be this on top. So this is your FMO negative 1. Then your FMO plus 1 is the frequency after the modal class frequency, and we refer to it as the post-modal frequency. So that's going to be this one, FMO plus 1. So that's the meaning of those terms there. Our C is class width or class size. And of course, in order to get a class width, you can obtain it from either the class limit by doing upper class limit minus lower class limit, or you can obtain it from your class boundary by doing upper class boundary minus lower class boundary. Once you are able to obtain all these terms from the table, your problem is solved. Simply substitute them into this formula and then calculate. What you obtain is your mode. Take notes. The calculation method by formula gives accurate results compared to the graphical method. Of course, the reason is simple. In the graphical method, you would have to select a scale. After selecting the scale, you would have to trace points. Of course, errors due to parallax might make your result not to be absolutely correct as it should be. In the next video, we are going to take question and see how we apply this formula. Now we have this question on the board. Let's look at it together and then solve using the scores of the sample of 45 randomly selected students in a statistics examination in table 2A. Calculate the modal score of the students. Alright, so this question is based on table 2A. We'll recall that we already established this table 2A previously, okay? So for this problem, to solve it, I just extracted the columns we need to calculate the mode. And what do we need to do? We have to recall the mode formula, okay? The mode formula is equal to XMO plus open brackets FMO minus FMO minus 1. That is the pre-modal class frequency divided by 2 times the frequency of the modal class minus the frequency of the pre-modal class minus the frequency of the post-modal class. So we're going to multiply all of these by what the class weight C. Now we would go to this table and quickly identify our modal class. And what is the modal class? You would recall it was stated that it is that class with the highest frequency. So we would locate the frequency column and check what is the highest frequency there. Can you tell me? Alright. I agree with you, it is 10. Okay, so this is the highest occurring frequency. Therefore, this class gives us the what? The modal class. We can pick all our data from this class. Is that okay? Which is the modal class. Now let us go. XMO, which is the lower class boundary of the modal class. So I'll go to the class boundary. The lower class boundary of that modal class is 64.5. So we're going to write 64.5. Okay, then move on. The frequency of the modal class already we've obtained is 10. Then we'll get the frequency of the pre-modal class. Okay, frequency of the pre-modal class, that is the class before the modal class. Its frequency, look at it, is 8. Just the class above the modal class. That's 8. We're going to obtain the frequency of the post-modal class. Frequency of the post-modal class, the class just after the modal class, the frequency is 7. Now the class width, we can obtain the class width either from the class boundary by doing upper class boundary minus lower class boundary, or you obtain the class width from the class limit by doing upper class limit minus lower class limit, then you add 1. Is that okay? Take note of that, please. I didn't state it previously. I'm now saying if you're using class limits to obtain your class width, it is upper class limit minus lower class limit plus 1. Or you can go by counting straight from the lower class limit to the upper class limit. For example, from 50 to 54, we are counting 50 and 54 inclusive to be 50, 51, 52, 53, 54. Alright, I prefer using class boundary to obtain my class width, so as to avoid any mistake. So we're going to go to the class boundary, do any upper class boundary minus the lower class boundary, okay? You can do any one of them, but let me just use that of the modal class. You still obtain the same result anyway. So it's going to be 69.5 minus 64.5. 69.5 minus 64.5. It's giving me 5, so our C is equal to 5. We are as good as done. We can now substitute into the mode formula, so that our mode will now be equal to the XMO, that is lower class boundary of the modal class, is 64.5 plus open bracket frequency of the modal class is 10, going to minus frequency of the pre-modal class, which is 8, divided by 2 times frequency of the modal class, which is 10, minus frequency of the pre-modal class, which is 8, minus frequency of the post-modal class, which is 7. We're going to multiply everything by the class width, which is 5. Alright? So if you work out this, how do you go about it? Have 64.5. Okay, be done with the bracket first. Finish up everything in the bracket first. If you come to the bracket, how do you go about it? The numerator is 10 minus 8, which is going to give us 2 all over. Denominator, of course, you know the rule of Borg mass, you need to be done with multiplication first. 2 times 10 is 20. 20 minus 8 is what? 12, right? Then 12 minus 7 is going to give us 5. So this is over 5 times 5. Do you know that mathematically? Remember, you must follow the rule of odd mass. So this plus 64.5 is the last thing you need to do. Coming over here, this 5 will cancel this 5 if you seek to open up the bracket. So you'll be left with 64.5 plus 2. So 64.5 plus 2 will give us the mode by calculation for this problem to be equal to 66.5. Of course, it's going to be in percentage because the scores of the students were given in percentage. Of course, you can see how easy it is to solve this problem, okay? There is no difficulty in it. You want to obtain mode from calculation. First of all, simply identify the modal class from the table. Is that okay? Then from the modal class, you can get all of these parameters. Once you get all of this data, substitute and simplify, you get your result.